You're watching the 5.5 Factoring Trinomials Day 1 notes. This happens to be one of my favorite topics in algebra. So I'm glad that I am doing this video notes with you. And you guys are going to find that this is your favorite topic too. So let's talk about it. All right, number 1, the graph of f of x equals x squared plus 2x minus 8 is shown right in front of you. I already graphed it on my calculator. Disclaimer, if you don't have your calculator, please, please, please use desmos.com right now. So desmos.com. Okay? Otherwise, it's just not going to be as fun. So you should totally have fun with me by graphing. All right, here we are. We need to find out its roots, which are, if you remember, from Unit 2, the x-intercepts. So bust out that highlighter and highlight those. So what are the roots? Those roots are x equals 2 and x equals negative 4. All right, so what we want to do next is we want to graph this on the same axis. Oh my gosh, g of x, they're the same. Did you see that? They lie right on top of each other. What does this mean about f of x and g of x? They are the same. What? That is so weird. How is that possible? All right. What do you notice about the roots? So the roots compared to the binomial factors. So what do you notice about the roots? X equals negative 2. Sorry, x equals positive 2. Why isn't that erasing? X equals positive 2 and x equals negative 4. Compared to the binomial factors. So that's what that x minus 2 and x plus 4 mean. Oh, they're the same. Oh, wait. Are they? Positive 2, negative 2. Negative 4, positive 4. That's weird. So wait a minute. They're the same. They're the same number, different signs? I wonder why that is. Okay, well, let's prove this algebraically. So let's prove that the two binomials x minus 2 all times x plus 4 is the same thing as x squared plus 2x minus 8 using the glorious box method. All right, so boy, did I draw a crazy box. That looks terrible. All right, well, I'm not redoing it. So x minus 2, x plus 4. You guys love this method so much, don't you? Yeah, me too. All right, x times x is x squared. 4 times x is 4x. X times negative 2 is negative 2x. 4 times negative 2, negative 8. Check out those 4 beautiful multiplication questions. Like terms? Yep. 4x minus 2x is 2x. So the drum roll to make sure that these are equivalent. We're going to take our x squared, our positive 2x, which we see this up here, minus 8. My constant, is that the same? Yes, it is. We're happy. Let's put a check, smiley face, and a star because this is so amazing. All right. So here we have this steps to factoring trinomials. We can always revisit this if we need to. One thing that I do want to tell you is that your calculator makes you show roots. So if you go into the menu, you go to Analyze Graph, and, well, it doesn't say roots, but 0 is another word for that. We have them here, and then we could do that again for the other one. So if there's 2 roots, we have to follow this process twice and find them that way. The reason why I had to actually click on the graph in this problem was because I actually have 2 together. If there's only one graph on there, it wouldn't have asked me that question. So another thing to write down here, which might be nice, is you can do menu 6-1. This finds zeros or roots or solutions, whatever you want to call it. All right, and another thing to keep in mind, when we factor, we're just rewriting the polynomial. All right, this is kind of cool. So let's go on to this question here, or, well, these 6 questions here. And what it wants us to do is we're going to factor these trinomials, but we're going to do it in a very, I want to say robotic way at first. But as we're doing it this robotic way, I want you to be thinking in your amazing little brains, or big brains, whatever you want to call them, what is happening? What are we doing? Can we find a shorter method? All right, so we got to graph 1, 2, 3, 4, 5, 6 functions. So pause the video. I'm going to actually graph them to save some time, but I'd like for you to pause the video and graph them on your calculator on 6 different pages. Or if you're using Desmos, 6 different tabs of all these 4 different things. All right, here's my graph for number 1. What we need to do first, and I'm going to do this with every single one of these questions first. I know it seems like we're going to be skipping around, but the reason why I want to do this way is so that you can see the connection between all of these questions. So number 1, it says to find the zeros. If you're getting stuck and you can't find them, go ahead and use your calculator to identify them. Here's a 0, there's a 0, everywhere a 0, 0. So x is equal to -9 and x is equal to -3. All right, here's my graph for number 2. I could also count, where are those? X is equal to +3, x is equal to +8. Remember, we're just finding the zeros of places where it crosses the x-axis. All right, number 3. Oh, there's only one of them, huh? At -2. Wait a minute. That's not right. I need to see a U. I don't see a U. It sure looks like maybe that U is curving, so maybe I need to change my window, I don't know, to like -20. There she is. I could go all the way down if I wanted to. I guess I don't really have to. But if you want to see the U, we could change this around and then play around with finding the zeros. But I think if I count, one of them's at -2 and the other one -11. How am I doing? All right, let's go down to these ones. Number 4, here's my, wait a minute. Is this graphed on here? Yeah, I'm positive I graphed this. I think I gotta change this around. I don't know, should I try like 20 maybe? Oh, there's one. Oh my gosh. How about this one? Maybe -20, see what happens here? That's so weird. Oh, and haha, you caught me. I did this beforehand, and I found my zeros already. So one of them was at -12, and one of them was at +12. That's cool. Even though it's a binomial, even though it's an x squared, it still gave me those 2 zeros. All right, number 5. When I first tried to graph it, it yelled at me because I typed in A's. And then I remembered, I have to type in X's because my calculator only understands X language. Okay, so what are my zeros here? They are at -3 and +7. All right, and my last, wait a minute. My last one, it's only 1? That's so weird. Okay, well, that's at +7. All right, so now if we take what we did in the first problem, the factored form just looks like these 2 binomials, right? So I often refer to this as a non-mathematical term called the skeleton template. I don't know if there's like an actual word for it. I don't think there is, but this just helps me to see the structure of how my answer is going to look. And then I'm just going to fill things in. So what we learned from the first page is we take our zeros and we write them, but instead of x minus 9, see how I'm not putting an equal sign in there? I'm going to write it as x plus 9. So the opposite sign. So if that's a -3, that would be a +3. Okay, let's do the next one. That would be a -3, and this one would be a -8. So x minus 3 times x minus 8. All right, number 3. What is it? X plus 2, x plus 11. Yep. All right, number 4. Let's take these zeros. So x plus 12, x minus 12. Number 5. Remember, we have a's here. So a plus 3a minus 7. And 6 is weird. I don't know what is up with him, but all I have is x minus 7. And I know that x minus 7 isn't the same, so we got to figure out what goes in that other one. I'm not understanding it, so we'll wait on that question. Now, what I want you to do, because all of y'all can do this, pause the video, distribute to check on all 5 questions. Ready, set, go. All right, that was pure magic. Did you see how cool that was? That somehow this strategy has made all of these factored forms like connect to the original trinomial, and I don't know what's happening. Well, actually, I lied. I do know what's happening, but do you know what's happening? I don't know. Let's keep thinking about it. So I did this on all of my questions. So 1, 2, 3, 4, and 5, and it worked out beautifully. It was just pure magic, like I said. But number 6 was all weird. So number 6, I can't figure this out. So with number 6, somehow I had the x minus 7, but in my box, I'm supposed to be getting like the x squared minus 14x plus 49. So let's think about this one here, because this is going to help us with what we're going to do on the next day. And hopefully it's going to help us make some connections. So don't I always get x squared here? Right? Isn't that where like my squared terms always fall in my boxes? And then the plus 49, isn't that this little dude down here? And then don't these combine to be that middle term of negative 14x? All right, so I got to figure out what goes on the other side. So let's play this guessing game. What times x gives me x squared? Oh, that's x. I got that. That's easy. All right, let's try the next one. So I think it would be easier to find that positive 49. So negative 7 times what is positive 49? Well, 7 times 7 is 49, so doesn't that have to be a negative 7? Wait a minute. Wait a minute. So isn't that now negative 7x and negative 7x? And what are those together? Negative 14x. Holy cow, we found it. So this here was my other missing special factor. So what did we learn here? When there's only one zero, it's really the same factor, copy and paste, multiplied by one another. Couldn't I write that another way? Couldn't I write that as also x minus 7 all squared? Okay, so in summary, what did we do? Whenever we needed to factor, at this point right now, we're graphing, we're looking at the zeros, finding the window, changing the window if we need to, and then we're taking the zeros and we're writing them as opposites in the factored section on the factored form. So when I'm factoring, my answer is all of these. So these are all my answers on all of the questions. Notice how we distributed to check on every single one of these as well. Okay, this is a great setup for our next topic on factoring trinomials, which would be the next day.